Powers. Time to learn about powers. We're not talking about the force like Luke Skywalker is using here to make these canisters levitate and to make sure that his shirt doesn't fall up or down, I guess. He must have been using the force for that. Anyways, let's move on and talk about numbers powers, like powers in math class. Here is a power. It's called 4 to the third power. We could also read this as 4 cubed is another way to say that. If it was actually 4 to the second power, we could read that one as 4 squared. Very common ways to talk about those two particular powers. If the exponent is a 2 or a 3, then we could say squared or we could say cubed. Let me undo some here, though, and get back to our 4 to the third power here, or 4 cubed. The 3 is called the exponent, and the 4 is called the base. Together, both of those things make what's called the power. That is what we'll be talking about. There are certain rules and properties and things that we have to follow when we're trying to simplify expressions that have powers in them. Let's look. First of all, when we're multiplying two powers, like the a squared and the a cubed being multiplied together, see the little multiplication dot right there, there are certain rules that we have to follow. Let's use what's called expansion to see the first of those rules. So a squared means that a is being multiplied by itself as a factor 2 different times, and that's told to us by the exponent of 2. So a appears as a factor twice in a multiplication problem. Then for the a cubed part, it appears 3 more times because of the cubed, or the exponent of 3. That means in this multiplication problem, the same exact base appears as a factor 5 times. Twice from the a squared part, twice from the a cubed part, simplifying it to a to the 5th power. This could be simplified and all of this work skipped. We don't really need to expand like was done here. Okay, expanding is kind of just a waste of time, but shows you why and how it works. This could be simplified thinking to ourselves, if I'm multiplying powers that have the same base, in this case a, then I can just add the exponents together and do the 2 plus 3 to get the exponent of 5 for the final answer, or the simplified answer on this. Let's move forward and take a look at all of these properties. So the one that we just looked at was multiplying powers that have like bases. So in this property here, b is the base, m and n are different exponents, and those can be added together. That's the one that we just looked at. There are other properties, and we'll go over more of these later. The other ones that I guess I want to go over right now would be, so we went over this one. Let's also go over this one really quickly. This one is called the power of a power, because this power is being raised to its own exponent. If I expanded there, I would have b to the m. Let's use the example. The example over here has 9 to the 4th to the 5th. That means 9 to the 4th gets multiplied by 9 to the 4th, and this should appear 5 times. This is the expansion, and so there's the 5th one of those. And now I've got bases that are being multiplied out. I could keep expanding and call this one 9 times 9 times 9 times 9, and then this one 4 more 9s, and then 4 more 9s, etc. There would be a total of 20 9s when I was done. The simplified way to figure that out is just to multiply those two exponents together and get 9 to the 20th. The last property here that we want to talk about is anything to the 0 power is always equal to 1. There's actually kind of another property that I wish was here. That last property is that anything to the 1st power is the same thing as itself. Okay? When something is written without an exponent, so there's no exponent there, that just basically means there's one of those invisible ones, kind of like the 1 times x equals x, or x divided by 1 equals x, or x plus 0 equals x. Well, x to the 1st power, that's just another way of writing x. And so there's always an invisible 1 exponent on any number that doesn't have an exponent written. Okay, let's look at some problems. So these ask us to simplify. Remember that when we multiply powers with like bases, like here, I can add the exponents. So this is really 2 to the, well, 6 plus 8 is 14. So 2 to the 14th. Again, I've got like bases, negative 3's, and there's an unwritten 1 there, so this is really negative 3, and I've got to put that in parentheses because the negative is part of the base, and that's to the 8th power. We should look at and compare sometimes what happens when I don't put parentheses there, how that makes a difference. Problem C, well, there's a negative 7 to the 3rd, negative 7 to the 1st power, and negative 7 to the 4th, which I believe makes negative 7 to the 8th. And the last one, the variable is the base, so m to the 1st power times m to the 5th times n to the 6th is really m to the 12th. And I'm just adding 1 plus 5 plus 6 in my head to get that 12 for the exponent. Moving on. Evaluating versus simplifying an expression. Just a moment ago we saw 2 to the 6th times 2 to the 8th. And this simplified to 2 to the 14th power. I did not evaluate this because I didn't get my calculator out and multiply 2 times 2 times 2 times 2 times 2 14 different times and then figure out that that's equal to 16,384, some huge number. That isn't what we were looking for. What we're looking for is, do you understand this property of when I multiply powers with like bases, all you have to do is add the exponent. Simplify to here. If it asks you to actually evaluate the expression though, then actually give me the numeric representation where there are no exponents, and this is not written as a power anymore. It has been evaluated. Okay, so that's what evaluating means versus what simplifying means. Okay, the next property is to multiply powers that are being raised to another power. So the 3 to the 3rd power to the 6th power is the same thing as 3 to the 18th power. Remember, on this one we're multiplying the exponents together. So negative 12 to the 7th being raised to the 6th is the same thing as negative 12 to the 42nd power. And again, I need the parentheses around the base so that I also know that that minus sign is being raised to the 42nd power also. D to the 5th squared is the same thing as d to the, do you know? 10th. That was a bad 0. That's supposed to be a 0 there. And then x minus 3 to the 3rd to the 4th is the same thing as x minus 3. Leave the base alone. Don't change anything inside the base. And it's just these that are getting multiplied together to make the new exponent a 12. Okay, this next property is showing us that when we multiply things that aren't like bases and raising them to some power, then this is the same thing as 16 to the 4th power times 21 to the 4th power. That is all we can do with that. Unless they ask us to evaluate, we cannot go any further. Okay, we are not going to multiply the 16 times the 21 first. I mean, we could. The order of operations would tell us to do that. But in some cases, you're going to have a variable in there, like in problem B. Okay, there's nothing that can be simplified using the order of operations inside those parentheses. So the first thing, or the only thing to do is to apply this property. 6 cubed times m cubed times n cubed. The next one would be negative 5 cubed times p cubed. And this last one, we'll notice that the minus sign is outside the parentheses, so it's not being raised to the 4th power. So the answer there is going to be negative 2 to the 4th, and notice that that's different than me writing it like this. So negative 2 to the 4th, q to the 4th. That's all I can do. Okay, here's an example where we're going to actually apply a lot of those different properties in one problem. First, I'm noticing this little 3rd power here to the 3rd power. So negative 3 gets raised to the 3rd power. And this y to the 5th gets raised to the 3rd power, so I have to multiply those exponents. So that's y to the 15th times 2y squared. Okay, now I've got like bases for those, and so I'm going to add those exponents. So I've got negative 3 cubed times, I'm just going to put my numbers out in front, so I've moved the 2 in front of the y term, times y to the 17th. And there I've used several different properties to simplify this down. If they asked me to evaluate, then I would get some kind of single number for that part, times y to the 17th. Please do problems 9 and 12 and have those ready for a warm-up tomorrow. Good luck!